Okay, now let's talk about projection, okay? There are two different projections, okay? Scalar projection and vector projection, okay? But they are really related to each other, okay? But I believe you learned about the concept of scalar and vector projection from your teacher, right? So like for this video, and we're gonna try to practice how we can calculate the scalar projection and vector projection, okay? Here we go. So let me give you the formula first, okay? Scalar projection B onto A, okay? Actually, the direction of like vector is important, okay? So what is that? We notate by comp P B onto A, okay? That is equal to dot product of two vector over the base vector, length of base vector. That is your scalar projection. And vector projection, same thing, B onto A. We notate by project B onto A, which is same thing, dot product over the length of A times the unit vector of your base vector, which is A over A, okay? So when you look at your textbook or your professor's lecture note, you are not gonna have this form, but you're gonna have this form instead, okay? So because like you have like same thing on your denominator, it will be squared, A, B over the vector A squared times A, okay? So look at that. Scalar projection is not the vector anymore, okay? It is number, okay? But your vector projection, it is still vector because I get this one. A dot B over length of A squared is the scalar, and but like this one is still vector. Is that okay? So let me apply like this formula to your problem, okay? So, okay, so look at number 10. Your vector B, let me use different color. Your B is 4, 8. And then A is 2, 1, right? Then the scalar projection, which is comp B onto A, is equal to A dot B, which is 2 times 4 plus 1 times 8 over the length of A, which is square root of 2 squared plus 1, okay? That is equal to 16 over square root of 5, okay? So what about the vector projection? We notate by project B onto A, right? That is same thing, 2 times 4 plus 1 times 8 over the length of vector A squared and vector A, which is 2 and 1. So which is equal to 16 over 5 and vector A. Then we can write this one as 32 over 5, comma, 16 over 5, okay? So again, scalar projection is the, like, number, but like your vector projection is the vector. Is that okay?